Introduction. ISMR is a very complex phenomena because it has many domains involved into it, like geographical location, atmospheric conditions, oceanic conditions, etc. Because so many domains are involved into this, we have many variables which can act as predictors, and these variables may be very strongly related to monsoon. It may be related weakly to monsoon. Sometimes it may not be related, but still is present in the climate scenario. So in such cases, we have a question of which variables to select to consider for prediction. For good accuracy, it is obvious that strongly related variables have to be picked using some selection technique. So contribution of my paper is shortlisting possible ISMR predictors from literature study, 36 climate variables, which we call it as large set. Association rule mining is used for predictor selection. It also serves as dimensionality reduction mechanism to overcome memory and time constraint. C4.5 classification algorithm is used for prediction, and the combination of the above said algorithms have actually given us considerable improvement in the prediction of Indian summer monsoon rainfall results compared to previous study. This was the literature survey. What we have done is we have listed all the variables in which work has been taken place, and against each variable we have given the paper references. We have considered only those variables which have more paper references, because we have gone through, we have taken the concept that those variables which have more paper references are deeply studied, and those which have less paper references might be in the infancy of their research, or might have been active only for a smaller or shorter period of time. Hence, if you see the considered variables, it has totaled up to 36 variables. So what data sources and data preparation, how have we done is available over here. Data, availability of raw data was not enough. For example, if we are taking temperature as the predictor, availability of data from January to December is not of use for us. But actually, if we take the averages of March, April, May months temperature, this particular variable or average is very much a good predictor of Indian summer monsoon rainfall. So hence, such calculations and fetching trends we have followed for each and every variable which we have specified in the literature review. These particular fetching trends and calculations have been solidly backed up by paper references already present in the field. Next is data source. We have used this Tropical Meteorological Department data and NCEP, National Center for Environmental Prediction, and National Center for Atmospheric Research. These reanalysis data from the models of United States of America. We have used these particular data, and this is the standard data used in the current field. Next is data preparation. Because we are using this data and data mining, we have clubbed the similar instances into one range. Each of the variable data is divided into 5 ranges. The threshold values are determined by, calculated as plus minus 1 plus minus 0.5 of the standard deviation from the average. So data mining techniques we have used is association rule mining. We have 36 variables plus 1 rainfall variable, amounts it to 37 variables. We have used 37 years of data. So combination of this will form a huge dimensionality, and we know that drought and flood doesn't occur in common in nature. So obviously our minimum support threshold will come very low. In such cases, a priori algorithm is not apt for usage because it gives us memory and time constraint based problems. Hence we are using closed item set mining algorithm. An item set is closed if none of its immediate supersets has the same support as that of the current item set. Minimum support we have set is 0.058. So if we would have used a priori algorithm, we would have got around 20 to 30,000 frequent item sets. In this case, closed item sets, we are getting around 1000 frequent item sets, closed item sets, from which we are selecting 2 to 4 association rules ranked according to confidence. Then we are using classification algorithm S1140035 decision tree based, which gives us the following, we are using the classification algorithm. These are the association rules for all India region rainfall. Because of time constraint, I can't explain each and every variable importance, but I would like to tell the first this thing. Equiwind is nothing but the wind speed that crosses the equator. Next, Nino 4 is nothing but the temperature at a particular specific location in the Pacific Ocean. Equino phase is the temperature phase at the equator in the Indian Ocean. So what we want to, how we read this particular association rule is equiwind when it is in the range 3, Nino 4 when it is in range 5, equino phase is in range 2, all India region rainfall will amount to drought. That is this thing what we can see over here. And this confidence actually gives the importance of that particular association rule. Similarly, if we go to deficit, Srinagar wind at range 3, Bombay max temperature at range 3 and Nino 4 at range 3 gives us a deficit for all India region rainfall. So how we have selected these particular variables in the last column, we can see we have taken all the antecedent variables and we have listed it over here. These we call it as selected variables. This amounts to 21 over here. This is for only all India region. Similarly, we have done it for peninsular India and for West Central India. West Central India, we have got around 20 selected variables, and for peninsular India, we have got around 13 selected variables. After applying classification algorithm on the large set data, large set is nothing but all those 36 variables. This selected is nothing but the 21 which we specified in the previous slide. So when we see the error rates, we can see that selected variables have performed better compared to large set variables. For example, 0.83 is the error rate for large set variable, and it is 0.74 for selected variables. Similarly, in all columns, West Central India also shows a difference and Peninsular India also shows a difference. And finally, this particular row, it actually gives the error rate of previous study done, and we can see that our model is performing better compared to the previously studied model. Only one problem over here is Peninsular India is not behaving as per the other two regions. This is probably because Indian summer monsoon rainfall is not, Indian summer monsoon is not a chief rainy season of Peninsular India. Peninsular India is also affected by northeast monsoon. That is why what happens is, when we if we see this particular experiment, we have used only summer monsoon rainfall predictors, and if we are supposed to use, if we use northeast monsoon predictors also, this particular results may improve. This is the future research directions. That is, we can, because it is a complex phenomenon, we can add some more variables to improve the results, considering long intervals of data. That is, we have used only 37 years of data, 100 years, 200 years, like that would improve our results. And instead of using crisp partitioning, we can use fuzzy partitioning for value-based predictions. And models like neural networks, anything other than C4.5 can be experimented for improving the results. Thank you. And any
questions from audience? Okay. What are the data you used for simulation?
Sir, I showed you that 36 variables, no, sir. Out of that, rainfall and temperatures we have taken from Tropical Meteorological Department, and other things we are taken from NCEP, NCR reanalysis.
Then you said something about that US data, that is NCAR.
Yes, sir.
That how come it holds good for this? The Indian
Sir,
climate.
actually, this is not model based data, sir. It is observed data only. Like usually what these people do is when we take observed data from Indian region only, they collect from different places, and wherever the data is missing, these people would have used their statistical algorithms, and they would have given the missing data also, so that we get very clean data. If at all I had to take this particular data from Indian region or Indian IMD or something like that, I had to sit and clean it. I had to run the statistical algorithms and all, because this is not a model data. It is observed data only, but clean data. It is more reliable compared to our scenario.
No, even though it may be that US climate and then Indian climate is just can't. And then instead of US climate, you would have gone for that nearing.
No,
country.
sir. Collected data is not from US region itself. US people, they collect data from different regions and keep it in their place.
US only intended.
Yes.
Okay, that's what. Instead of C4.5 classification algorithm, you would have gone for some neural. That's a fine. Right?
Yes, sir. This
So it
was
would have been
just
given
for
some intelligent algorithms. You would have used
Yes.
that machine learning algorithms.
Sir, actually this was just for the proof of concept phase, sir. I've gone through, I've proceeded this phase, and I've gone through the next this thing also. I'm using regression equations for this particular thing, and it is giving me very good results. We are getting around 97% accuracy, and IIC professors are also interacting with us, so that they can just take this model for improving their own understanding of the particular problem.